hopefully we'll have more than 20 viewers today, maybe. Yeah? Ready? Are you ready? All right, so if you're ready, then welcome to ReactNYC. Woo! Yeah, it's a nice layout, like I have to turn to see everyone now. Welcome to ReactNYC, BC2dRkm8ATU. Raise your hand who knows what this means. All right, 2 people, that's great. So we actually are planning a big reveal, and the big reveal of these hashtags will happen once we reach 2,000 subscribers on our YouTube channel. So we're missing about 500 more. Hopefully this year, we'll tell you what this all means. Raise your hand if you're here for the first time. Awesomeness, perfect. So for those of you who don't know, can you see the screen from here? Is there a way to put the screen on this TV as well? Thank you. So this is our Twitter channel, NYC React, for all the people there. So what you need to do is you need to go to Twitter, create a new post, take a photo, upload that, and then if it's good, we're going to retweet it. If it's bad, you can delete it and not post it. So that's how we can get new followers. We also are filming our meetups and putting everything online. First of all, big applause to Roman, who does all this work by himself, more or less. Yeah. So if you go to youtube.com/ReactNYC, you can see all the talks for the past, I don't know how many meetups. I think it's over 80 talks right now, which is awesome. And also, hi everyone on the live stream. Yeah, we're streaming our meetups. If you're listening, say hi in the chat. Okay, so whoa, let's not get ahead of ourselves. So for all the people who are here for the first time, so ReactNYC is a semi-monthly meetup. We run events like this every 2 weeks, and besides that, we also do like free workshops and master classes from time to time. So there's a lot of things to stay tuned to. And we usually have 3 to 4 speakers every event, which means we need a lot of speakers, between 6 and 8 speakers every month. Which means we're looking for speakers for junior engineers, for mid-level engineers, for senior engineers, for tech leads, for designers that work with React. If you want to talk about cool libraries that you used, or some technology, or some ideas, or something controversial, like why you should use Vue instead of React, or something like that, come talk to us. And even if it's your first time, we're going to help you prepare. We're going to help you build your deck. As I said, we are doing these events every 2 weeks, so the next 2 are planned for early September and late September. Small announcement. So we are organizing, we are the organizers of ReactNYC. We're also organizing a lot of meetups in Israel and a lot of conferences. And one of them is ReactNext. It's a conference that's been running for 3 years in a row now. Usually we have like about 600 to 700 people. So what's cool about that is besides the one-day conference with 2 tracks and 15 awesome speakers from all around the world, we also have a tour. So you can go there and combine business and pleasure. You can go to a tour, go to Dead Sea, all the cool stuff. And also we have a 10% off for all the members of the ReactNYC meetup. Just go to this link, the fhtnyc/NYCnext, and hopefully see you there. Want to say big thanks to ZocDoc. First of all, huge round of applause. Really awesome pizzas, really awesome place, really nice layout. I like it. I want to invite Jason to talk about ZocDoc just for a little bit, so you know what they're doing.
Yay. Hey everybody, thank you so much for coming. Welcome to ZocDoc. How many of you know, okay, there's a bunch of ZocDockers here. But of the people who aren't the ZocDockers here, how many of you have used ZocDoc before? No, we do those kinds of, oh, this is awesome. So the rest of you, download the app now. Download the app. But welcome to ZocDoc. If you are looking to make a doctor's appointment, this is the easiest way to go. And we are got a whole list of fantastic doctors, make it really easy to find your insurance, and we do lots of cool stuff in React as well. So we're super excited to have you all here. We're also hiring, so go to the site and check that out as well. But thank you for all coming. Enjoy the pizza, the beer, and all the great material we have here. And shout out to Luke, my guy, who's going to be on the docket tonight.
Thank you, Jason. So the plan for today is going to be like this. We're going to have 2 speakers, then we're going to have a break with our traditional quiz, and then we're going to have another speaker, and then we're going to have another mysterious speaker. We have a tradition for a few meetups now that we have a 4th mysterious speaker. So stay tuned for that. Don't go home after the break. By the way, I wanted to say, I want to apologize for the miscommunication we had earlier in the beginning with all the NDAs and stuff. So for those of you who didn't sign, it's great. For those of you who signed, we shredded them. So we're all covered. So big thank you for coming to the meetup, for spreading the word. Keep bringing your friends, and enjoy. Let's start with Lucas without further ado. Big round of applause. You ready?
Oh no,
it's this.
Yeah.
I got it.
Thank you very much. Hello. Ah, okay. But this is
Yeah, there are 2 microphones.
makes sense.
One is for you and one is for the people on the live stream.
Thank you very much.
You got it?
Let me see if I can. All right. So, all right. Good night, everyone. My name is Lucas, and I'm going to talk today about better UIs with state machines. First of all, I'm Lucas Reis. I'm a senior front engineer here at ZocDoc. This is my Twitter handle. So yeah, follow me, I'll follow you back, this kind, yeah. All right, first question of the night is, did you go from infinite planning to no planning at all? So back in the day, most of you are very young. You didn't see that day where we had like, I don't know, months of planning, giant specs, and life was really miserable at that time. Today, we're like agile in an agile world. We are super like fast and iterating, and now a lot of our projects have no planning at all. So, oh, this is what I need to do. Yeah, let me start coding because boom, agile. So my claim is we're getting too far to the other side of the panel. We are losing a lot by not planning. Planning is okay. And the first question I get when I say that is people are like, what, are you bringing back waterfall? So waterfall was what was happening back in the day. And I'll just say, no, it's not waterfall. I'm only claiming that we need some planning. I'm talking about like 2 hours of planning instead of 2 months. Even minutes of planning could be good. And for a really complicated like page or component, 2 days can save you weeks back in the line. So, coding is more costly than planning. Writing code, changing code is more, it's going to be more costly than erasing a whiteboard, draw, and then drawing again. Also, I claim that we are able to solve big problems and catch bugs with planning. Like if you look really carefully and if you are very precise in your specs, you can find a lot of problems even before coding, and this is good. And also the best part of planning is that during planning, we can leverage knowledge from people that are not coders. We can collaborate really close with the designers and the business people, and they usually know a lot about the domain, things that sometimes we as engineers, we don't know all the details, and also really smart people. We want to collaborate with them. So having that said, now that we're sold that planning is good, I'm going to say the finite state machines are a great tool for planning UIs. First of all, what are those? So here we have an example of a finite state machine, a really simple one. We have 2 states, off and heating. This is a model of an oven, right? So we have this 2 states. We have an initial state, that arrow over there is pointing to the initial state. We have 2 events, a bake pressed and off pressed. These events, they trigger state changes. So whenever bake's pressed, I go to the heating state. Whenever off's pressed, I go back to off. Super simple. We can make it as complicated as we want. For instance, here I'm modeling an oven that when it's too hot, it triggers the too hot event and transitions to idling. When it's too cold, it goes back to heating. And if I press off, it doesn't matter if I'm on heating or idling, I go back to off. So I can just go building the specification of my Ys with this model. So summarizing, we have a list of states. We have one initial state, a list of events that trigger transitions between those. Two things I didn't show in those models. Transitions may be conditional. We can have guards, like only transition to that state if this condition is held. And also a state can trigger actions upon entering or exiting a state. I'll go more in details later about those. So problems with that simple model is that our UIs are complicated and usually have a problem of state explosion. So we have like so many states that the model is not helpful anymore. So a really smart guy named Harel in 1987, he developed this state charts concept, which is, you can think of them as an expansion of the normal finite state machine model. So in this case, our oven model, you can see that we have the off and the baking state, but inside the baking, we have a substates. We have a machine state inside that state. So whenever I enter baking, then my first state is heating, too hot, too cold, blah, blah, blah. When I press off, I go back to off. This is a great tool, the substates, because we can zoom in and zoom out of our model. So we can think about the problems in a really separated way. Another, it's too small, I'm sorry, but another expansion of the state machines that state charts give us is we can have parallel machines. In this case, I have the oven and I have the oven light. So I can press light on and off independently of what's happening in the oven. And this, when you have a normal finite state machine model and you have like n different states, you end up with a combination. So this, we can avoid the combination and only think about the two machines. A third concept of state charts that we can see here is the off-pressed event that is issued by the oven also affects the oven light. So we have broadcasting. So we can, parallel machines can also react to the same events. So when my lights are on and I press off in the oven, the lights also go off. So summarizing state charts, we have hierarchy, we have parallelism, we have broadcasting. So state charts are great because they're high level enough to be able to be developed by non-coders. So people from business, people from design, they can develop a state chart together with you. And it's low level enough to actually help you with your code. So this is a great quality of state charts. It makes your specs more precise because the business and the design, they need to make it precise to be able to be a valid state chart. And your code gets more correct because you're using the same documentation for your specs in your code. Having said that, since we're on a React meetup, let's implement a React component using a state chart. Oh, are you ready? Yeah. Okay. Let's do this. First of all, I want to build, since we're in ZocDoc, let's build an insurance speaker. So imagine that the person in the website wants to choose their insurance, right? So we need to choose a carrier and we need to choose a plan. This is a really simple model of insurance. Insurance is extremely complicated. I just moved to the United States in 1 year and it's crazy. But this is like 90% of what we need with insurance. So let's say I have already selected here a carrier. I can choose my plan. The carrier and the plan are being shown in the input. If I click, I can reset. I'm loading asynchronously this list. I can get here and choose one, green cross, green shield, loading, all right, I don't know, PPO, something. This is the insurance speaker that I'm going to implement now with state charts. first thing we do, we prototype using Sketch System. This is a great website that lets you prototype working state charts. So here I can click open. Now I'm the carrier selection substate of open. If I click inside, I go. I want to show you really quick here. This is the website, and this is what produced my example there in the deck. This is really simple I can create a new state here. Let's see, I want to create a reset insurance state. You can see that the reset insurance state is created here, and I want it to react to the reset event and go back to carrier selection. So if I do it here, and I'll make my plan selection go to that, I can start here. I'm closed, I click, I go to open, select my carrier, select my plan, reset, I go back to select. Okay, so this is a great prototyping tool. There was some live encoding there, did you see? Yeah. I'll try not to do any more than that. All right, so next step, now we have a great prototype. Let's create a state chart using the XState library. XState library is a great library for managing state charts, and you have a JSON representation of your state machine. This is the JSON representation of the first oven model. So you can see you have the states, the off, the heating. So you start writing your state machine in this format, and you can see your state machine in the visualizer. It has a great tool. I can copy this. This is the visualizer tool, XVis tool. So if I am starting to see here. So if I change names, if I change events, I can add everything. This is a new environment to work with your state chart. All right, going back. This is the resulting state chart of our simple insurance speaker. So here we have two parallel machines. We have the input is a machine. The drop-down menu is another machine. The input is a simple machine. It's empty. If I select the carrier, it goes showing carrier. If I select the plan, showing carrier and plan. If I reset, it goes back to empty. In the drop-down, I have visibility. Also with some transitions, responding to events. And I have the insurance options, which is actually the machine for the contents of the drop-down. They are here, and I even have some loading states because I'm already putting in my state chart the information that I am fetching stuff asynchronously. So this model is the exact model that I'm using in this code here. So this is being generated by that model, and I'm going to show how. So I'm going to use a library called React Automata to create the component. I already have my state chart, my JSON state chart, remember that? So before I talk about my React code, back in the oven model, what was missing there? What was missing in my oven model? It was too high level. What was missing is the actual food. There was no mention of food in the model. It's like another level. So the food is your business state. So this is going to be handled by React when we use React Automata. So in the state machine world, we call it extended state. So first thing I do if I'm creating a component with state machines is declare my extended state. So all the state that I'm going to manage with React is this one. Selected carrier, selected plan, the carriers in the plan, which is already really great because this is all the business data that I need. And this is the important data too. I don't have those crazy booleans. The lights, yeah, something happened to the lights, but okay, I'll continue. I don't have those, lights are off? Okay, all right. So I don't have those crazy booleans like is loading, is transitioning, is error. Like those booleans make your code crazy, creates a big ball of mud here I only have the state that we care about. So first thing I do, declare the extended state, the state that is not being used in the finite state machine. Then those actions that I triggered, like when I enter a state, they're methods in my component. Here I have fetch carriers and fetch plans. I set the state with the carriers after I get them, and then I transition, I generate the code. Transition is a function that React Automate gives you. You just say transition and put the name of the event. The machine will take care of everything for you. And also you have like a collection of components to use that render only conditional to the state you are in. So this is the code. Like if I am in the menu visibility shown state, I'm going to show what's inside. If I'm in a loading state, here there's a really cool wildcard that I can use and makes it even simpler to show what to decide what I'm going to show. And of course, in the end, hire the component, plug it in, your state chart, your component. That's the size of the component. This is the only code that I used for that component. So it's 80 lines of React code, which is, I was really surprised by how lean was my component. Going back, this, let me show in the code sandbox. This is the actual code that we are using. So this is our insurance speaker that we just implemented with the reset and the click outside, everything. And this is the component that is generating that view. So we have here like just 4 methods, a render function. Here's 90 lines because I stripped the blank lines. This is everything. I have the state chart, and I have this component here. So let me go back here. It really worked well and with a lot less code than I thought it would be in this case. This is a complicated, a complex component that was made really simple. What I like about this process is that most of the time I spent in the sketch systems prototype and the X state, like doing my finite state machines. And at that point, I was collaborating with designers and with business people if I was in a real situation. So we would be leveraging everyone's knowledge to create our React components and not go into our DOM and stay there for a while and then like just like, oh, I don't remember that part really well. Can you clarify? Or there's a new state, you need to make a new screen. For me, overall benefits of finite state machines is that preciseness of specs and correctness of code. That component works. I have no doubt it works. React Automate has even a feature that generates automatically a bunch of tests for you with all the different states and creates snapshots of those. So it's really important. In a particular React app, because finite state machines can be used with any framework, but on a React app, it leads to smaller React components. There was a lot of less noise, less unimportant states. The only state we were managing was like important business states. There were no if clauses at all, so no room for crazy errors with all those booleans. And I had a lot of design help from the tooling, from the sketch system and the X-State visualizer. So in the future, we can expect more visualization tools. We can expect more ways to integrate JS. And what I am really excited about, we will have more tools to assert correctness. So I can see there's a lot of room for people to analyze those state machines and say like, oh, you have 3 dead states, or how quickly, I can ask questions like how quickly can I get from state A to state B? How many events does it need to happen? Things like that. This will all help us with the correctness of our code. Current problems may bring unwanted complexity to super simple components. So if you have a super simple component, don't use it. It will get in your way. Another problem is lack of familiarity from devs and designers. So it's not easy. You need to dive into it. So you need to study. You need to understand like your spec really well. Some people just like jumping into familiar code. And they're still a small ecosystem, so there are not a lot of libraries yet. The ones that exist are solid, but it's always good to have great ecosystems. So that's it. Thank you very much. Also, remember, ZocDoc, we're hiring. If you're interested, just talk to me or any other of ZocDockers that you see around. I also have a collection here of the most important links related to state machines, React, and JavaScript. And that's it. Any questions?
Right, let's take 2 questions traditionally. So there's 1, there's 2.
For state chart, right? Is there any standard like UML you have to follow when you actually say draw state chart?
Could you repeat the question for the?
Okay. The question is there a standard UML notation to build state charts? Yeah. So I'm using here the XState library. That is it seems to be becoming the standard library for state machines in the JavaScript world. And it's just a JavaScript object with a really simple documentation on the website. So yeah, you need to write it that way. But it's no UML tooling. You don't need to.
Thank you for the presentation. What happens if you transition to something that's not actually allowed? Does it just ignore it, or does it blow up? Or
yeah, you have those 2 options. You can. Okay. So what happens when you issue an event and your state is not ready for the event? It doesn't lead to a transition. Is that the question? Okay, so you have 2 options. You can, there's an option in React Automata, if I'm not mistaken, or XState, that you can say make it an error or not. So in real world, if you have like a hardware button in something and you don't want the button to do anything, the button will be there. You can press it and nothing's gonna happen. Like the button of your joystick when the console is like turned off. You just don't respond to it, or you can make it throw an error. So it's an option. Yep.
Okay. Thank you so much.
All right. Thank you.
Can I take it off? Check, check. Oh, that's much better. Hi. I don't know how to start. First of all, hello. That's my 2nd time in New York, and I'm really excited. The weather today was really nice. I'm just like walking around, see something. Oh my God, that was awesome. So I guess everybody's here. Organizers asked me to stay here. So I'm really sorry for people at my left. You will get less laugh than people at my right. People at my front, you just get everything like streaming around. And people, hello people online, really like to see you. So my name is Marina, and I'm going to deliver a talk about serverless and React. And before, I really want to start from my inspiration about it. About a year ago, I started looking into something behind the front end. That was my daily job. I just did some deployment, a little bit of backend, and it appears that serverless is awesome technology. Like serverless computation, database, everything's so cool that abstracts complexity from front-end people. and that makes us to really build things without thinking too much about what is going on there. And on my opinion, that time, and actually right now, I think it's really underestimated by front-end community. And I'm not the only one here, you know. My first version of this talk was around a year ago. That was kind of a crappy one, but that one better, I promise. And just before this version, like a day before, Chris Coyer, actually, do you know this guy? Do you know who's Chris Coyer? Oh yeah, that's, for those who doesn't know, he is behind, he behind the CodePen, CSS tricks and such things. So he tweeted this, and that's exactly what I'm thinking, like we need to get more attention into this. Of course, he did much better job than I am. He put a lot of materials in here, a lot of useful links. What I do, I will just do fun, easy demo for you to just show that things is not that scary and it's worth to try it out. But you know, let me start from proper introduction. I'm sorry, I'm just walking here saying hello, Marina. My name is Marina, and just jump into the talk. I am solution architect in EPAM. And my day job is basically jumping around the projects, doing some funny stuff that I really enjoy. So I'm not going to talk about my projects, I just talk what I'm doing, like with what technologies I work, because it will affect what I'm going to talk after it. So that's AWS at my day job. And all the serverless I'm going to do is going to be on AWS. Also front end, I like it a lot, but my day job mostly with React and React Native. Also because I am a solution architect, I do a lot of documentation that's boring, let's skip it, and just a little bit icebreaker, you're so quiet. 3 fun facts about me. I have a dog. I really like everything about spaceship. I'm not that much into it to understand what is going on there and like have a meaningful conversation about it, but if somebody talk about it, I just get shivering under my skin. That's honestly, that's so cool. And I really want to go to Japan, and one day we'll do this, just buy tickets, but not today. Next time, honestly. And then let's go back to the business. So what I'm going to do today, as I said, that's going to be a demo, and basically you're all right now in the, like this huge code review. And to make it even more fun, I decided to do it like a novel. So that's going to be part 1 of exposition, then going to be main story, and we will finish with resolution here. Let's start with exposition. Unfortunately, if you want to do serverless, just having cloud function, cloud computation is not enough. You need to use a bit more services, and I'm going to talk right now mostly about AWS because you saw my day job is on AWS, but other providers, they have very similar ones. So I'm going to use S3 for set storage. I'm going to use IAM for manage access rights. I'm going to use API gateway for creating URLs. And guys, I'm really sorry for those of you who knows AWS, because right now I simplify things a lot. I'm not lying, not lying, but people who know AWS, they may say that it's not quite correct. That's just simple, right? I want to have things casual, let's keep it like this. It's not like. And with this, let's move on. I will use CloudFormation for deployment and AWS Lambda later about it. And as I said, it's really, really important for you, for those of you who didn't try it yet, just go home and try it. I recommend it. And that's cool thing about it, that's going to be free. So it's free for AWS because it has free tier. That's going to be free for all other providers like Azure, Google Cloud, because they also have free tier. And let's move on. AWS Lambda, what is it? And actually any cloud function, what is this? Like every serverless, like every wireless connection, there is wires. Serverless has servers underneath. So that's how things work. So we do have servers. We do run our function on this server. We run it inside container. And basically all this like whole configuration of a function inside container and server is Lambda or Cloud Function. And the cool thing about it, why I love it so much, you can't forget about servers, like completely. You don't think about these boxes. So, and what that means, the big thing, that's scaling. So potentially and theoretically, things can scale infinitely. That's not like these people who know it, but at least for a small scale, we can think about it. And let's talk a bit about it. So scaling, how that works. Request comes in, we have a Lambda running. 2 more requests comes in, while our Lambda running, we have 2 more Lambda spin up. We can handle it, no problem, because it's like infinite computation, right? More requests come in, we got lucky, our site is popular, and we have more Lambda serving our site. Terrific and easy, so we're gonna stick with this one. And with this, we're done with exposition and we can go to main story. As I said, that's a demo application. After this thing, you can go to my GitHub and try it out. And right now, I just go briefly over the code, so you're gonna be familiar with it and you can play with it even more. First of all, that's how the application gonna look like. That's extremely simple. That's a server which uses YouTube API underneath. You put some words, it will return some videos and render it. How it works with some diagrams, all right? I'm solution architect, I like to draw diagrams. I'm a C user, I go to the website, and then my browser will get somewhere and ask for this website. We don't have service, so that's why our browser will go to API gateway. And API gateway is already this cloud thing. API gateway will trigger Lambda. Lambda will render our page, return it back. It will return back to the browser, renders in there, and then browser realizes that it doesn't have some static assets. What it does, it goes to the S3 bucket. As I said, we're going to use it for storage our assets, get some bundle.js, CSS, fonts, images, whatever you put in there, and then it can render our site. Browser happy, user happy, we're done. So that's basically server-side rendering. I guess a lot of you is very familiar with it. So let's move on. And if you go to my GitHub, you will see this project structure. I said we're gonna do code review, all right? So that's gonna be some code. That looks like this. There is a lot of code, but don't be afraid. I used a lot of auto-generation. I used Facebook generate React application. I used Serverless, which is framework for deployment lambdas, to generate some code for Lambda for me. So that's why I'm not going to go through all the files, just some very interesting, just something that I changed by myself. That's going to be config, packages, on, serverless UML, and source. We'll start from config. So if we go in there again, a lot of pre-generated, the only thing that matters is webpack config Lambda. I need to create another webpack configuration so my application can be compiled and rendered and run on Lambda. What matters in here? Not much. Just render my React and Redux for not target. That's it. Then I will go to packages zone. Here I just need a few more scripts. One to run my Lambda locally because I need to test my site locally, and another one to deploy Lambda. That's easy like it is. And then we go to serverless UML. That's a really small one, and serverless is a really great framework. I didn't talk about it a lot because it has really limited time, but check it out. It will generate Lambda to you, it will deploy for you. And the most important thing in here is this line. So it will point to our Lambda function, which is actually a Node.js function, nothing much. We will look into this later. And another one, I will just specify the webpack config, which is gonna compile my code. Then we're gonna go to source. Inside source, the only folder which matters is Lambda. And inside it, happy you, we have only 2 files. That's going to be fast. I will start with handler. That's most important one. And if you remember the serverless configuration, that was actually our Lambda. And that's our Lambda function that has only, how many, 5? 5 lines. If I throw away all meaningless lines, it's going to be 3. So that's pretty cool, right? What is interesting in here, I do really want to catch all the exceptions which rise in my Lambda, because I don't want to show something crappy to user. I want to process it right. And the second one, when it writes the exception and we don't process it right, our Lambda is going to run a little bit longer, like 3 times longer. You don't find it in the spec. That's something that I just tested. So you really want to process it. And another one, create response one. This one just a wrapper which adds status codes and headers to my HTML string, which just render it right inside the browser. And then we go to rendering function. That's a magical one which comes from the renderer. So let's go and look into this one. And here's the trick. I'm not going to show the whole code of renderer, because what is going on in here, first of all, it renders isomorphic application. Is there people who know how isomorphic applications work? Oh, hi. 3 of you. Yeah. 5, maybe 6. I didn't see everybody. But yeah, that's server-side rendering. That's quite complicated. That's whole another topic. I'm not going to talk about it. It requires a lot. So I just did a brief Googling for you. You can do it by yourself and find all these pretty tutorials and look through these. Honestly, that's worth looking into. So I just skip it and just tell that main part of my renderer.js is rendering isomorphic application, everything that I need to do with it. Then it comes to error handling. That I said, it's really important to catch the errors. What I did in this one, I used promises, just because naturally I do some AJAX request, it will return promises, so I use promises to catch it and then do something like process it. And then the another one, we will have 2 environments, which is really differs one from each other. One is local environment, another one is AWS. And I want to have my files on local run from localhost, on AWS run from S3. So how I can do this, of course we need to create the variable, and then we will look into the environment variable as well, how I can pass it. Again, serverless UML helps me a lot with this. I just pass the environment, it will automatically apply to Lambda. And bingo. So the hard part over. Congratulations, you got everything working. You got your Lambda, which gonna render your website. You don't need any service in here, and you will have nice ECO optimized application running. So let's go to the resolution part. The very first question that people ask usually advantages and disadvantages of doing the Lambdas, doing cloud functions. So what I can tell about it, if you want to know about advantages, I encourage you, go to the provider sites like Azure, like AWS, like Google Cloud. They have so many advantages listed here. It's so nice, sweet, and cheesy there. You will buy it. If you want to know about pitfalls and disadvantages, don't go to these sites, please. It's not the right source. Google it, and the one article I really like, that's again from the Serverless. These guys really know what they're talking about because they did do a lot and they work a lot with the Serverless. And they actually did really good overview of what's going on with this and when you need to use it and when you don't need to use it. So what else except like server-side rendering you can do with cloud functions? Basically everything. I mean, there is a few limitations in here, but everything. Just a few examples. HTTP services, like REST services, naturally works good with all cloud functions. And again, did you notice this a smooth transition? I'm not talking about lambdas anymore. I'm talking about all cloud functions from all providers. Then we can go IoT. Alexa works with lambdas. Chatbot, the same thing. Image video conversion, machine learning, by jobs, and it's only things that fit in my screen, all right? There is much more of this. And if we will ask what else except AWS, there is a lot. Google, of course, has Google Cloud. Azure has some functions, IBM functions. Twilio also has cloud functions if you want to use it. And this wild world of open source, I love it. What they did, like the main and big disadvantage of cloud functions, you get vendor lock, right? Which is not really cool. Open source will release it. So they have a lot of implementations of FAAS, which is function as a service. And here are just some random list. I tried a few of them that works like magic. And you don't have any vendor locks. You can run it on DigitalOcean anywhere you want, going from AWS to Google Cloud, whatever you like. And with this, that's it. Did I make it in time? Thank you. Thank you.
Thanks, Marina. Who has 2 hard questions?
That need to be hard. He promised me.
Yeah. Yeah. 1, 2.
Hi, thanks for the talk.
Oh, my pleasure.
So what about performance? How is the performance of the Lambda generated website?
Just repeat the question for the
Okay, so the question was about performance of Lambda generated website, and that's actually very, very good. I mean, you can control how much CPU you have, how much memory you have by selecting the size of Lambda you want to run. And there is, I don't know how much details to give in here, but okay, let's go like this. We do have, in my practice, in my project, we have server-side rendering running on servers. We run it on EC2. And we have big issues with scaling, because if you get a lot of traffic and you need to spin up another EC2, it's 5 more minutes. With Lambdas, it runs the same fast if you have it already running and spin up another Lambda. In the worst case, it's a few seconds. So no complaints about performance. So there is some issues with performance if you will go, for example, running WebGL, but WebGL performance is like rendering is pretty bad with Node.js at all. You don't want to do it in Node.js. So that's the thing.
Hi. Thank
Hello.
You. I really like using service functions. I think they're awesome. Lots of fun. Something I struggle with is testing, like rapid testing over and over again with them. Do you have any tools, solutions, frameworks that you use for testing these service applications?
Okay, so the question was about the testing, which is very tricky, like testing, monitoring, and auditing of serverless computation is really painful thing right now. So for testing, we just use regular libraries we use to test Node.js. So that's just Node.js function, we test it like a Node.js. If we want to have some test environments, we use local stack. That's the NPM project, which will emulate the AWS environment locally inside Docker, container, Kubernetes, whatever you use. Again, you can argue with me that it's not a real AWS, but it's better than something, than nothing. And yeah, that's it. There is like a lot of things to do in terms of testing and monitoring. So unfortunately, that's not that perfect as I want it to be. Thank you.
Another question. How are meetups in New York compared to meetups in Los Angeles?
One more time?
How are meetups in New York compared to meetups in Los Angeles?
Oh, you put me in a very uncomfortable situation. You are all great, all right?
Yeah, thank you.
Thank you. And can I
BC2dRkm8ATU here? No. Let's make some noise. Who's here for? All right, not too much. So the rest of you know what to do, yeah? Put your phones on the air. What's the Wi-Fi? You don't need any Wi-Fi. All right. Yep, let's go to Kahoot.it. Take your phone out. Don't worry. We don't have any privacy policy for this app. So while you're all logging in, we suck all your private data from your devices. We will share this content. What? Can't you hear me? You want me to share it? What? Music. Oh, where's the music? It's supposed to, it says like it.
No music today.
No music today.
Imagine the Kahoot music.
Yeah. Who's the DJ? All right. Come on, sign in. The only quiz in the city who's got no prizes at all. So, yeah, you got absolutely no reason to do this quiz. Total waste of time. Help us to know you better. Use a fake name. Use your real name. Use the name of someone you know. We're going to hack your email anyway. Is there anyone here still trying to connect? Anyone still trying to connect? Raise your hand, please. I'm going to count. I'm going to count down, and then we're going to start. All right? So, 10, 7, 6, 4, 2, 1. Last chance. Yeah. All right. So for the newbies, the rules are: you're going to see a question. You've got 20 seconds. Please be honest. Help us to help you. Ready? Are you ready? Yeah. Woo! Stuff like this. All right. Yep. So the first question for today is: do you know React? I can say, yeah, you can put some music. Are you an expert, ninja, superstar, whatever? Oh, great music, romantic. And how many ninjas? Ninjas, raise your hand. Where are you? Well, yeah, you ninjas, yeah. We can't see you. Are you looking for a job? Hmm? Help us to help you. Oh, it's wireless, so I can do like beatboxing. I'm good, meme. No. 2 seconds. All right. How many? Oh, who's hiring? Raise your hand. All the job seekers. Look at these people. All right. We're gonna have a break soon. Just Attack them. Don't let them go. What would you do for your ReactNYC community? We, the organizer, we do a lot of stuff for you. Yeah. You want to give a talk?
I would shave you.
Yeah? I will let you shave me for the community. Yeah. Let's do it. That's a deal. Next anniversary of ReactNYC, I'm going to shave my legs because, all right. Yeah, so guys, spread the word. Twitter, all right? Use this hashtag. Who's going to shave? 15 people. Who wants to do a tattoo? We pay for this tattoo. Are you serious? Come here and, yeah? ReactNYC. Yeah. Which framework the person in the picture use? Come on, racist. Yeah, we can recognize them. This is a Vue.js hipster? Nah. Let's see. Oh yeah, yeah. All right. You should be ashamed of yourself. You're laughing. I'm a front-end developer because. What's the reason? Look deep inside. Be honest. It's totally okay to make your mother happy. I mean, that's life. Let's see how many people here to get a date. Valid reason, if you ask me. Don't ask me. Nothing, ever. All right. Who's become a front-end developer to get a date? Just you and you. All right. Who's hiring for a date? What do you do when you're not coding? This is an anonymous quiz, all right? Help us to know you better. This is not Windows XP screensaver. This is an authentic picture. Sport activities. All right, how many people running naked in an open field? All right. Good for you. And for the field. How old are you? Yeah, have you punched cards? Think about it. COBOL is still relevant. All right. Punch card, raise your hand. I use VS Code because. All right, let me read it for you. I'm not perfect, which is fine. No one is. I like to be inefficient. That's totally okay. I'm from Canada. Anyone here from Canada? No? No Canadian? Sort of? All right, can't afford Webstone. Yeah. Who can't afford Webstone? You can't afford Webstone? Here's a license, free license for you. Because you're honest. Yeah. He's honest. All right. Use it. You can choose whatever idea you like. All right. Next. You see, when you're honest, good things happen. All right. Why do you come to ReactNYC? We're very inclusive, so if you got nowhere else to go, that's fine. We're here for you. I can hug you after the session. How many hungry people did we feed today? All right, eat food for free. Important. Thank you. Now we're going to take a break, and after it, we've got another talk, yeah? And then something mysterious is going to happen, so you should stay.
My name is Alex Holachek. I work at Code Academy as a front-end dev.
Wait a second. Guys. Thank you.
And today I'm going to talk to you about the flip animation technique and how you can use it to bring meaningful motion to your UIs written in React. In terms of my credentials, I don't really have any, except for this summer I've spent a lot of time looking at React and animation in an effort to avoid having to go outside at all, which has been successful. But here's the sort of the fruits of my summer of no sun. Okay, so first of all, why would you want to use flip animations in your interface? And why do we even care to transition our interfaces from one state to another? So what does that add to the user experience beyond some cool transitions that might be eye-catching if you're lucky? So I think Sarah Drasner put it really well in this quote that I'm going to read out as to why you might care about adding these transitions. She writes, "Transitioning between two states can reduce cognitive load for your user. Without these transitions, changes can be startling. They force the user to remap placement and even their understanding of the same element. It is for this reason that these effects become critical in an experience that helps the user feel at home and gather information quickly on the web." Okay, so let's look at a little example of an interface with and without the flip animation technique. So I made this little icon store demo for this talk, and we'll be looking at it a couple times throughout the talk. And I'm not a designer, so caveat there. But so here we've got a GIF of the user sorting various icon sets that they can buy and changing from a grid to a list view. It's quite abrupt. There's no transition. Here, let's look at what flip gives us. So here's the same set of transitions, but they're smoother. To my eye, at least, it's a lot easier to follow sort of what's going on with this interface. Again, you could quibble about timing, but in general, I prefer this sort of view. And flip lets us do this pretty easily. So before we get any further, I'm going to show you how to implement flip from scratch. So first, flip is an acronym that stands for first, last, invert, and play. So what does this actually mean? I think it was invented by Paul Lewis, or at least that's the first article I read about it, was by him. And I think it's been around for a little while. So the first part of flip is we have this element that we know is going to change, and we want to animate that change. So we know an update is imminent, and we cache information about the position of the element. So this is what that might look like. We know this square is about to change, and we're going to call the getBoundingClientRect method on the square, and that gives us this nice handy DOM-rect object that has top, left, width, and height, and also some other stuff that we don't care about. So we've got that. Then there's last. So the update has occurred, and we're going to do basically the same thing. We're going to measure the new size, the new position of our element. And I will stand here now, or here. Yeah, so now this is sort of like the most complicated and important part, the invert step. So this is what that looks like. The top 4 lines are calculating the translate and scale transforms we need to apply to cancel out whatever changes have just occurred. And we have to do this very quickly before the user has noticed any difference or any movement in this element. So to find the necessary position deltas, we're subtracting the current values from the previous values. To find the necessary scale values, scale deltas, we're dividing the previous size values by the current size values. So we know that we need to move the div back up and back 100 pixels, and we need to have its width and double its height. And that's basically flip. So now we're going to just play the animation. We're going to add maybe a simple CSS transition, and we're going to allow the div to smoothly transition back to where it was before. And that's sort of the simplest implementation of flip. Okay, so you might be asking, why do you need to do it this way? Why can't you just use translates and various CSS animation just like you're used to? So let's look at an example of why flip would be better in some situations. Okay, before we go any further, we should remind ourselves that we can really only animate these 2 CSS elements if we want to ensure performant animations. And that's because they're GPU accelerated. They don't cause the browser to have to do layout or repainting, its transform, and opacity. We can actually do a lot with these, just with these 2 elements. But yeah, so you could probably animate left or margin left or any of these Attributes, basically, if you had like a really tiny element that didn't really affect the layout of the rest of the page, but once you start changing the layout of the page, you're going to really want to stick with these two properties. Okay, so a designer comes to you and they're like, I have this idea for this cool new animation, and I was wondering, like, can you cost it out? How difficult is it going to be to implement? And then you're really excited, and she shows you this incredible animation of the square getting bigger and filling the entire screen. And so if you're like me, you might think a little bit and say, yeah, this isn't too hard. I can totally do this. And you might write some code that looks a little bit like this. It's just a React component that listens to component did update, or it listens to a change in a prop that I can't quite see, but I think it's like full screen. Yep. And when it detects the change, it's going to like measure the difference between the square and the size of the window, and then it's going to apply the translates, or apply the scales in this case, to make sure that it's a full size. So this seems to work pretty well. You can indeed implement this animation using that technique. But things start to break down pretty quickly with this technique. Like as soon as the user changes this window screen, you're going to have to listen to that, and you're going to have to update your code. You might, maybe the layout has started to change, and now you're sort of managing some things that CSS used to handle for you, because maybe you're using some absolute positioning, and you're sort of hard coding the positions of these elements. So to me, what I just described seems more of an imperative way of dealing with layout animations. You're essentially giving tons of instructions to the browser, you're taking over the job of CSS, and it could get messy fast. Flip on the other hand, seems a lot more declarative to me. You just build your layouts like you're used to, you manage the transitions in between them, and then you're done. You don't have to worry about it anymore. Okay, so why do Flip and React go well together? I'm going to talk about that now. There are a few reasons that they work really well. So the first reason is that Flip facilitates us to be able to write React like we're used to. I see I did not turn on my timer, so I have no idea how long I've been talking, but okay, whatever. Let's see. Yeah, so this was like the first thing I read when I was learning how to do React. I think probably some few people are familiar with it. It's the Thinking in React tutorial on the React main documentation. And the #1 step is you have to break your UI into component hierarchy, and your components should have a single responsibility. They shouldn't really interact with each other so much. You should really keep them separate. And Flip or transition animations seem to sort of go against that. They might require one component to morph into another component, and it might initially seem difficult to understand how you would do that without having these components know about each other. The second thing I learned in React, basically, or like the second bad practice I was warned to stay away from was excessive like dealing with the DOM. Like I should just let JSX do its thing and not really worry about that. And that's another thing that Flip kind of lets us do, is I'll show you don't have to manage like cache elements and manage their movement around the screen all that much. You're sort of like still pretty abstracted, and your DOM handling code is pretty localized. So here's an example, a really quick example from this demo app. Like I have a card and I have a page that the card expands to. In the React app, they're totally separate. They don't know about each other. One is the card component and one is a page. And Flip just sort of makes the illusion to the user that they're the same thing, but the rest of the app doesn't care about it. So we can use Flip to create that sense of continuity. Okay, so React also makes it pretty easy to implement Flip, because React has some really nice lifecycle methods that you can hook into. And so let's remember this animation and talk about how we might implement it in React. So here are the two lifecycle methods that we care about. There's get snapshot before update, and then there's component did update. So I think get snapshot before update was introduced in React 16, and according to the docs, it's invoked right before the most recently rendered output is committed to the DOM. So we have this like split second where we can measure the DOM. This is the first step of Flip. And then that's the information we return from that method is then passed on to component did update, which is called right after the update occurs. And the cool thing about component did update is it's called before the user has seen anything rendered to the screen. So it's this like magical in-between state where you can measure what's happened, and like the browser can tell you what will appear, but the user doesn't see it yet, so you can do any sort of like changing around that you want to. yeah, so we're going to then implement flip and move our elements back to their previous positions so we can do that nice smooth transition in this case. Okay, so as you might imagine, there are several flip libraries that have cropped up so that you don't have to write everything from scratch in React when you add this to your React apps. So I'm going to go through a few of them. React Flip Move, I think, is the most well known. It's really optimized for list transitions, not so much like scale animations or anything like that, but it's like pretty battle tested and it's like really easy to use. So if you just want list transitions, that might be a good one to look at. There's also React Overdrive, which sort of got me interested in this whole thing. And React Overdrive doesn't actually use flip. It just clones your elements and crossfades them, which is pretty flexible and it's really easy to implement. But it's not quite as smooth as flip. You can kind of see some transitioning going on there. But it might be perfect for your use case, especially if you just want like a really quick solution. So I'm going to spend the rest of the talk talking about the library I wrote because the pre-existing libraries didn't really meet my needs. And again, it's very possible that the other libraries are better for your particular use case, but I wrote this one, so I'm going to talk about it. And yeah, so React Flip Toolkit, I wrote it to have more flexibility and more power than the other options that I saw. So it offers some low-level components, so it requires a little more work from the developer to implement. So yeah, so if you want to do straightforward flip, React Flip Toolkit can help you with that. This animation that I'm sure you're sick of seeing by now, it looked like this when we implemented it from scratch, which is really not so bad. But with React Flip Toolkit, it requires a lot less code. We see here we have a flipper component and a flipped component, and I'm going to talk about what they do now. So the flipper component sort of is the parent container component. It might be at the top level of your scene or even above your router, and you provide it with a flip key that changes every time you want a transition to occur. So how does the flipper know what it needs to update? Well, there's the flipped component, and you can wrap any element that needs to animate with a flip component and provide a flip ID to sort of match it across renders. Maybe you have a cool div in one route, and then you have another cool div in another route, but they're totally different components, and then React Flip Toolkit will know that it needs to tween them. Okay, so you can do simple things, but like honestly, if you're doing simple things, you probably just want to write it yourself from scratch because it's not so hard. The real reason to use React Flip Toolkit is it has some more sophisticated things that it can do. So the first real-world problem that I sort of bumped into and was sort of frustrated by is that as soon as you start to scale things, you start warping anything inside of them. And so all these transitions that I was thinking of that seemed pretty cool in my head ended up looking pretty unpleasant when I implemented them. So React Flip Toolkit gives you this like option to apply a counter scale to children and cancel out what's going on in there. So here's like a simplified view of that card component that we just saw, and I've wrapped it with an additional flipped component that has an inverse flip ID that references the parent. We apply a counter scale, and now we can a counter scale and a counter transform so that children can sort of animate however they want to. So it looks like this in the fixed version. Yeah, the other major problem that I saw is that I didn't really normally just want to use flip. I often want to have some like preparatory animations or some post animations, and I wanted tons of hooks or like some exit animations if things are leaving the DOM, and I wanted to make that easy as well. So for instance, here's just like straight flip. We're just flipping, we're just transitioning some elements from one point to another. It's still a little abrupt. React Flip Toolkit comes with these hooks that I've already discussed. So this is sort of with the hooks. So like on a before animate, after animate, they sort of allow us to manage some of the other parts of the DOM. And this is sort of what that looks like. You've got these various hooks. Another thing that is pretty easy to solve ended up being that when I was applying flip, a lot of things were changing exactly at once, which didn't look supernatural. So React Flip Toolkit offers you this nice stagger option where you can stagger your transitions so it looks a little more natural. Cool. Okay, and as you might imagine, React Flip Toolkit maybe does a little bit of extra stuff so that you can have interruptible transitions. If you don't do anything, you're going to get something that looks like this, which is pretty cool actually, but probably not what you want in your app. Yeah, so all you kind of need to really do is like cache the current position and then strip the inline transforms so they don't start compounding on each other. But React Flip Toolkit does that for you. So I guess that's nice. Cool. OK, so I have linked to my README. I would love if you made issues, if you had questions or concerns about it. The demo app is there. I've got, these articles are really great and go into a lot more depth than I did. I strongly recommend looking at them. And yeah, and I really like this talk by Jake Archibald that helped me understand a lot about the way browser and the browser and the event loop deal with animation, and explanation of why you can only animate, transform, and opacity. And finally, the required slide, Code Academy is hiring, so if you're interested, please chat with me after the talk or email me. OK, thank you.
I have two questions. Up to two questions? Yeah, okay. 1, 2.
Hi. So what would be the difference with CSS transition groups? Just transition groups?
Yes. Yeah, oh, so he asked what would be the difference with using the CSS transition group. So CSS transition group works great if you just need like a simple CSS transition, but if you want one of these like major layout transitions where one component sort of like changes into another component, or you just want to handle the transition in between them. Like we kind of talked about at the very beginning about how like using CSS to take over some layout would start to become brittle in your app. So that's used more for like a fade-in animation or something, and this is more like managing the positions, I guess, of various elements. I don't know if I explained it really well, but yeah.
Hello, amazing, clever, like I need it right now. But my question, is it possible if, as we said, two components in different parts of the page, can we morph from one component to other? Like when you press on the link and it's open to pop up with your library?
Yeah, so if, oh, the question was like, can you morph from one component to another? It depends on like what the components, if like, for instance, that card animation worked really well because it was just like a white square that turns into a white page. And that worked perfectly with this, and it looked really smooth. If you have like two completely different components, like two images that you want to crossfade, I would recommend using React Overdrive. So it kind of like depends.
Thank you so much.
Thanks.
Thank you. All right, so now we have our mysterious speaker. We have a round of applause.
Hey everyone, I'm the mysterious speaker. Yeah, can you hear me? Yeah, I think something wrong with your equipment. Yeah, or something wrong with the slides. We've got some technical issue. No, I'm kidding. It's just a black slide. Yeah. So I'm not going to expose myself. I'm just would say that I'm part of the organizer of this meetup, and here in ReactNYC we hear you. So I like to invite you all to our new meetup. We're gonna launch it this Saturday. You're all welcome, of course. You don't need to bring literally anything. No, but yeah. Don't take pictures. Now, code of conduct and stuff. Anyway, my real talk today is gonna be about serverless React with AWS. So it's a subject that I'm sure that you haven't heard about it for at least 45 minutes. So I'm gonna get, no, I'm kidding. But you've seen your face. No, no, seriously, all right? That's a doctor, come on. What's wrong with you guys? There's nothing funny about this slide. This is the title for my lighting talk. It's not like an official talk because it's very mysterious, so I don't have too much slides. So I'm going to introduce myself, like, not really introduce myself, really, really fast, and then we get into the code and have some fun. All right? Yeah. All right. So this is me. I'm a principal consultant at 500 Tech. I'm also a Google developer expert in web. In 500 Tech, we help companies to build sophisticated front ends. If you want to know what we're doing, visit our website. You can see some cool stuff. But I want to tell you a little bit more about myself. I'm also a bodybuilder on my free time and a painter. All right. Now the reason I need to hide behind those glasses and mustache is because if you watch some of my talks in YouTube, and if you've seen one of my talks, I usually make fun of some technologies. This is a collection of slides that I usually use on my talks. I have people with PHP positive. I'm, as you know, giving some free licenses for VS Code. I've got the support group. So I made a lot of enemies. That's the reason I can't. I'm actually, yeah, this is a fun one. This is Teens with PHP, which is not fun. But no, I mean, you're laughing, and this is funny, and we've got a good mood, and and humor and stuff. But the slides that really got me into troubles was this cheat sheet, and currently, currently I've got some threads from a bunch of Vue.js developer from Brooklyn, so I need to hide behind this stupid costume. All right. Yeah. They can't recognize me. I've got a mustache. Let's talk about getting inside. How many of you are like beginners with React? Don't be shy. Oh, cool. So how many of you work with React for at least a year? Nice. 2 years? How many of you walk through the source code of React recently? Someone? Yeah, Ilya. Yeah. All right. So I want to share with you this concept. Actually, this sliding talk's got a message. It's much more than the actual content. It's about you can use the framework, you can use the tool, but if you really want to become a better JavaScript developer, I highly encourage you to take it a step further. Peek into the source code because you want to learn stuff about JavaScript. And the best way to learn the good stuff about JavaScript is to look into frameworks, because behind those frameworks there are really, really smart people who build something that all of us can use. So I built a playground, and I want to talk with you. It's going to take like, I don't know, 10 minutes or so about those subjects: freeze, seal, symbol, and friends, just without the friends. So I want to share with you my playground, Visual Studio, WebStorm, of course, all right? Yeah. So this is my playground. When I want to play with the actual framework and peek into the source code, I just, simple HTML file. I grab the React development and React DOM development, just download them just extract them from the node modules. And basically that's it, an empty JavaScript file. And if I want to render something to the screen, it's, let's try to do this. App component, don't need to export everything. No JSX, no imports. Very simple and straightforward. So it's going to be React create element. Let's create a title. Thank you. Yeah. All right. And then we need React DOM, render. Let's render it to the screen. Let's take our app. Put the music on. Thank you. Yeah. I can't talk and code, you know. I'm a man. You're laughing. But that's the truth. Hopefully I didn't forget. Yeah, why? Why, how, and where? What did I miss? Component is not defined. Of course it's not defined. All right, makes sense? Yeah, I think so. All right, so this is my playground, and the reason that I'm putting together this project, because now it's very, very easy, you know, just to command click and see what's actually going on. So I want to talk about some stuff. Let's start with this React create element, all right? So React create element, what it does? Who wants to answer? Create an element? Which kind of element? Which kind of element? DOM element, like browser? H1 what? Oh, yeah. So if you do something like this, let's save the element for a second and return the element. So we can just, you know, log it. We find out that React create element got nothing to do with the DOM. It's just returning a simple JavaScript object, and that's it. Actually, if you go into React source code, which is not that long, a lot of comments. That's the reason you've got 1,000 lines. But if you strip all the comments, if you look at the minified version, it's literally nothing. And if you search for things, I don't know, like document. I don't think you can see my search. Or document, you won't find it. Yeah, of course. You won't find any document. You won't find anything that got to do with DOM, with the browser. Because React as a library is just a library for creating dynamic trees. The whole virtual DOM is just a nested object, which is cool. So who's responsible for actually taking this object and make it a DOM element? React DOM, exactly. So this is where the magic happens. This is the method that knows how to take a simple object and convert it into a DOM element, a real DOM element. And the reason for this is that if React is just a library for building nested objects, it's very easy to create your own renderers. This is how React Native works. You can create React PDF render, whatever. Write a function that knows how to take an object and output something else out of it. Cool? All right. So this is just for a starter. So if React create element, and we can look for it at the source code, we can go to React element, and where are you? Too many comments. Here it is. You see this? React element, an object. You've got a type of. We're going to talk about it. And then you've got some properties, and that's it. And you're returning the element. All right? So if React element is just a plain JavaScript object, I can do something like this. Element, and then let's do something with it. Let's add a name. Let's add my name. Make sense? Yeah? And then I got this exception. Object is not extensible. Why? Because is, give you a hint, Madonna is frozen, right? Great album. I don't hear it, but yeah. It's frozen, which means that if I try to do something like this, object is frozen. Let's see where it is. I get nothing. Yeah. I need to start with this, right? Then it got true. How many of you familiar with object.freeze? Not too much, which is not good. Let's talk about it, all right? Let's talk about React. What's going to happen now? Let's say that I'm going to create another component, title. And title going to accept title as props. And we're just going to React. Actually, I can take this one. React create element. And right here, instead of this, puts the title. Make sense? Cool. And here, I'm going to create element. But this element, let's just return React create element and just render the title and pass some props like title, hello. Make sense? Make sense?
Return.
Excuse me?
You should return that.
Oh, it's a render, yeah. Too much beers. All right? And we've got hello. Cool? Nice. Let's do this. Let's create a constructor. Yeah, let's call the super. Props right here. This state title gonna be playground, and here I'm gonna pass yeah, I'm gonna pass this state title. If you see a mistake, please correct me. All right, cool. Simple, straightforward, but I wanna do this. And let's pass all the props object. And let's do this. All right, still working. And now what's gonna happen now? I'm gonna take the props and just add something to the props. Let's add my name. Because props is just an object, yeah? And right here, props, my name. What's going to happen? I don't know, maybe. Nothing. Silence. Let's peek into the source code. Let's go to create element from React development. This is all the public API of React. This is the object to get exported. So you can, right here, you can, right? And for example, let's go here to component. Actually, we don't really care about component. We care about React element or create element. All right, and look at this line. Object freeze element props and object freeze element. So this object freeze, it's a very powerful method from JavaScript object prototype, because it's enabled you to freeze an object in a way that you can extend it and you can change it. So for example, if you've got some code and you just created this object, and you rely that this object got this name property, and you want to make true, because JavaScript is a dynamic language, so everyone can just do this: delete info.name, and then if I try to look the info, right, I've got nothing, empty object, but I want to protect it, so I can call object freeze. And then you can touch it. You can touch me. It's a famous song and a dance. All right, cool. But what if I want to be able to change the name? I want to be able to do this. Info.name equals someone else. Josh, all right? But the object is freezed. So I don't want you to be able to delete name. I want name to be exist, but I want you to be able to change the name. Change the value, but don't mess with the structure. So instead of freeze, I can use seal. And when you're sealing an object, it means that you can't add properties. You can delete properties, but you can change the values. And this is interesting. I'm thinking about React. Actually, I'm lying. I'm thinking about my beer and where I left it. But if I think about React, let's talk about refs. Let's go here, right here. Let's take the title back. We don't need this. Let's return a title. Just this state title, yeah? We okay? What? Where? Why? Return. Return. This is how you write code in Canada. You always do twice return. I didn't. All right. Let's talk about refs. Let's say that you want to take a ref to this object. So I want to do this. Ref equals this title ref. And here we're going to create a ref. This title ref equals to an object. We've got current, which is an object. And let's take the component did mount and try to log this title ref. What's going to happen? Who knows? You all failed job interview. who wanna guess? Come on! You said you're working with React. All right, I've got prices for you. Who wanna guess? Try, fail. It's a meetup. It's not like a. Excuse me?
The DOM element will be set to the title ref.current.
Yes, but this is gonna work. Like I can pass this object with current just like this. Apparently, yes. So what is this method? What is React create ref? Because this is how you actually create reference in React. You familiar with this? When you want to create reference, now in React, create ref, and that's it. So if you pick into create ref, you find something very interesting. It's just create an object and seal this object. So you've got a real use case of using seal. For example, you want to lock your object to an interface. In this example, I want to make sure you've got current, it's sealed. You can't add stuff, you can't remove it, but you can assign any reference you like, all right? This one is for you because you tried, all right?
Okay.
Now, I've got here a bunch of gloves. And those gloves are for you, all right? Because if you want to get deep into React source code, you're gonna, I mean, the real reason is that my keyboard is a mess. So you don't want to touch it like with bare hands. But I want to give you some gloves. So, if it's okay with you, gloves. It's clean, and new. All right, thank you. I've got plenty of those. All right, we don't have too much time, so let's look at another nice feature, and then talk about life and fruits. Fruits are important for your health. So why are you laughing? All right, look. If you go up the source code, up the stream, which most of the source code, sometimes we're afraid of the source code because it's the source code. But React specifically, it's plain JavaScript. So if you play with it, if you actually look at the source code, you can learn a lot of cool JavaScript stuff. Let's talk about this. those lines. I've got here a bunch of constants, React element type, and has symbol, yes, no. If it doesn't have a symbol, symbol for React element. How many of you are familiar with symbols? 1, 2, maybe 5, and all the guys that sits right on the back, all right? But we don't count them, all right? How many of you used symbols in your code? I can count 1. I can see you there, yeah, but you're sitting far away. Forget about it, all right. So what is symbol? Symbol is part of JavaScript. Symbol enables you to create a unique key for something. And I want to show you a cool trick. Let's say that you've got a class. Let's call this class, I don't know. Who wants to come with a name?
Fruit.
What?
Fruit.
Fruit. Nice. And you just won a $1 million chocolate. Yeah, this is for you. I'm trying to encourage you to make this session more dynamic and not just like me talking, you listening, all right? Ask questions, dare. What do you care? We just got everything filmed and we're gonna shame you on YouTube. No, that's it. All right, so we've got this class fruit and it's just JavaScript. So let's say that I've got this method print, and this method actually prints something, print fruit. And here I'm going to create an instance of fruit. What? Where? Where? Const. Yes. Yep. All right. And then let's call the print. Make sense? All right. And it's just JavaScript, which means that we can't protect this method. It can't be a private method. I mean, yes, I can create a function and a closure and return another function and just hide it in the closure. So we've got some patterns and tricks that we can hide this variable, but we don't want to use it because we've got this nice class syntax. So why should I use a function that return a function, hold this, whatever, all right? Let's say I want to protect this method. So what can I do? I can create a constant, but I can use symbol. Can give it a description that's not mandatory, doesn't really matter. And now I've got this print, and this print is a unique symbol, which means that I'm going to use another cool feature of JavaScript. In JavaScript, you can calculate your method names. So I can do this. And if I want to call this method, I can use this key. All right? And it's working. It's right here. You see it's working. So what's the deal? What's the thing? Why does it useful? If you don't have this constant, you can't call this method. So if from another file I'm just exporting the class, but I don't give you this symbol, you don't have the key. You can access this variable, this function, this whatever. Let's see some more practical example, all right? So let's say you're building a library like React. And as we saw before, we've got this React element. React element right here, all right? So it's just a JavaScript object, which means that maybe I can create an object by myself, and then instead of calling React element, I can just use this object. It's just JavaScript. But in React, they want a safe way to check that this object is a valid React element. So you see here this type of? You've got a type of which point to a symbol. So if you don't have this symbol, you can reference this. But inside the source code, you've got a reference to the symbol. So this way, you created a private key, so you can check against it. Make sense? So if you're building a library, if you're building a framework, if you're building a tool, if you're building something that you want other people to use, and you want to protect your code, and it's just JavaScript, those techniques, this API can really help you. And it's not like super sophisticated. I'm going to answer in a second. It's not like super sophisticated. It's just plain JavaScript. You can find it in the doc. Quick question.
Yeah. So would this be like an alternative for closure also?
Not exactly. Closure got other benefits. Oh yeah, we're gonna. If this gonna be a replacement for Closure, no. Closure is a completely different feature.
But I'm saying because usually where you use the Closure is to not have.
If you use Closure just for hiding properties, so yes, you can use simple. But Closure got a lot of other benefits and it's completely different. But yes, if you use Closure or any other those kind of patterns, or just for hiding or protecting your thing, use symbols instead. All right? Cool? Last quick line of code and then we summarize. All right, back to React. So we've got this React create element, we've got ref, title ref, we've got this state title, but what I want to do, I want to create another React element. So I'm going to do this, and here inside, this can be null. This is just properties. And right here inside, I'm going to create another React element with h1 with this title. And right here, I'm going to create another React element, which is a button. And I'm registering the onClick. And I can call this change title right here. And I've got, well, let's call it click. Let's implement this method. But not here, let's do it here. Change title. And we're going to change the title right here, right? No worries about it. React DOM development, blah, 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 DOM nesting. I made a mistake. Where? Where? Why? There. Ta-da, ta-da, yes, thanks. Yeah. But then I need to give it a key. Yeah. Each child is given a key. Yep, let's give it a key. All right, I think we're good, almost. Line 21, create element h1.
Line 21.
21. Yep, div, sorry. That was my intention. Believe me. All right, so we've got this one. Actually, by doing this without JS6, I think it's a great exercise. But if you really want to know what's going on, here you've got like a real life coding of someone like very tired. And again, we can learn a lot. You can help me fix this code because you'll understand everything that you're saying. It's not hiding behind JS6, so it's just plain JavaScript. You can instantly spot the problems. You should try it. You should take an Angular. Sorry, was a mistake. All right, I didn't say Angular. You can take a React component written with JSX, and just for the fun of it and for the learning experience, try to drop the JSX and use plain JavaScript. And then everything becomes very, very clear. Then you can understand the scope and why when I try to call this doesn't work, and props are just objects, and everything becomes very clear, all right? But let's change. Let's finish this light talk with this line of code. This set state, and let's set the title to new title. It's going to work? Yep. Cool. And here I'm going to log this state. So on line 18, I'm going to see state with a new title. Yes? No? Who thinks I'm going to see it? But be careful, I'm dangerous. All right. And why not? And why is it? Why does this method is asynchronous? Now you can't answer those questions, all right? The organizers can answer those questions. Who wants to answer this? Yes, please. Why this is asynchronous?
The function has to finish evaluating and pop up calls now.
Yeah, all right, yeah, that's technical, but what's the reason? I mean, it can be synchronized. I mean, theoretically.
Because the state didn't change yet.
Actually, if I'm gonna write this code, this updater, enqueue set state, updater, this is, well, come on, updater, yeah? We got it? I think so. Is this gonna work? What the Firefox just happened? I used the F word, all right? Uncater cannot print mode. I've got a typo. This updater, I can see the reason. I don't know what is this, I think. Oh, I'm just too tired for this. Let's do this. I'm not sure that's the problem, actually. Almost. Cannot read property mode of undefined. All right. I messed up with the live coding. That's happened. Let's give it a last try, and then we drop it. Yeah. Sad music, please. Dramatic sad music. We're gonna give it a last chance. Actually, I wanna start with just checking if I got this strange thing, this updater. No, it's null. Yeah. Excuse me? That makes sense. Hey, and I've got this updater. Interesting. Where did it came from? And I've got this enqueue set state. I just forgot the API for this, which happens. So let's go back to the final example and do this enqueue this state, but I'm going to pass myself, and then I'm going to pass an object with title, which is going to point to new title. And let's give it a last try. And it works, which is interesting. Where does this updater came from? I don't know. But the name of the method is telling us something, enqueue set state. So there is a certain queue. And I'm going to pass like an object to a queue. And if there is a queue, someone going to call, someone going to run. Something going to operate on this queue. Make sense? Yeah, all right. But here we're going to stop. Back to the slides. All right. So we looked at create element. We understand it's just an element. We learned some cool stuff about object freeze and object seal. We did some live coding, real live coding. No templates, real life. Errors, mistake, like the way we love it, all right? But we learned that if we're gonna play with React without JSX, we can actually understand what's going on. And we learned about symbols. So in just 10 minutes, with this like light live coding and a nice conversation, we actually, most of us, just learn few. How many of you learn something new today about JavaScript just from these 10 minutes? And that's the message of this talk, guys, all right? You can use React for years, but React gives you an opportunity to understand JavaScript better. So take this opportunity, create yourself a playground. All you need is a laptop, a WebStorm, a set of gloves, all right? And that's it, if you've got like a dirty keyboard like mine. Yeah, all right. So, all right. Let's summarize. Oh, and we've got this enqueue set state. All right. If you like this, we've got community-oriented workshops and the next one is going to be at September 10. And for 2 hours, I'm going to live code React clone from scratch. So we're going to implement our own React from nothing, all right? It's going to be very interesting. When I say community-oriented, I mean it's like $10, and you're going to learn a lot of stuff. So check it out. It's on meetup.com. And if you find it interesting, just come on, all right? It's going to be, I think, the third time we're going to do it. I promise you that you're going to learn a lot about how things work under the hood, all right? We don't try to make money. For each one who's paying for this conference, we're going to help people with PHP. I want to thank, I want to just finish by to thank my mother who's watching this live stream, which is probably the only one who watched this live stream. How many people have got on this live stream? 3, including my mother, 0. She just dropped. This is a random mother, yeah? This is not my mother. All right? If you want to follow me, this is my Twitter handle. I'm going to stay here, so if you want to hang out, ask questions, or whatever, you're welcome. Thank you very much for your time and patience. Pick some gloves on your way out. I've got plenty of them.
What about these?
Oh, license. Who wants to hang out after the meetup? I've got the licenses. Yeah.
All right, you give it?
No. You want to give it to someone? Go for it. Thank everybody.
What's up? Yeah.